So when you look what happened in terms of mechanism, I want to draw the attention that there are several different things. You have battery fire. You have runaway that will be defined as an increase of temperature, and you have thermal propagation. So runaway can be local or can be generalized, but thermal propagation will define the fact that maybe you have a cell that gets a problem, go and run away, and maybe you are not able to stop this cell to go on a runaway. But what you absolutely do not want is that the heat from this cell to contaminate, because it's too hot, to contaminate other cells and create thermal propagation, so other cells also to go on a runaway. So there exists method, and we are going to see together some of this in this webinar. About the mechanism of runaway, it's relatively complicated, and I could make a full presentation on 1 hour on this. But what you need to keep in mind here is that the timeline will depend on many things: chemistry of your cells, and also structure of your cell or design of battery pack. But in terms of temperature, we are talking here about relatively low temperature, if you compare that to internal combustion engine, of course. Because when you are already around 100 degrees Celsius, you are already quite in big trouble for going on a runaway trouble. And the way it works is that you have some chemistry that will release it because they have exothermic reaction. And the problem is that this chemistry reaction depends on the temperature. So the higher the temperature, the quicker this reaction to happen. So you will trigger a series of reactions that all of them getting exothermic, increase the heat and accelerate the process. And as the name suggests, go on a runaway. So it will involve mechanisms such as solid electrolyte interface decomposition, and it can make the separator of the battery cells melting, so you understand it's not a good idea to put in contact anode and cathode directly, or decomposition of the electrode, all of them releasing heat and ending up in a complete fire.